Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our decline curve analysis series, and we are still talking about B factor. So as you can see, we have three possibilities of production decline. The first one is exponential, where we have B equals to 0, hyperbolic, B between 0 and 1, and lastly harmonic, B equals to 1. So practically speaking, if you have exponential decline, it means that your production will decline faster compared to hyperbolic and harmonic. Why do we have slower production decline in hyperbolic or in harmonic? Okay, it's because in, for example, harmonic case, you will have another section of your reservoir contributes to the production later. So not all of the parts of the reservoir will contribute to the production at the same time. That's why you will have, like this one, like curved, different from exponential. In exponential, you can say, practically speaking, that all sections, all segments, all compartments in your reservoir are ready to produce. And when they are ready to produce, all right, then you will have faster production decline. But in harmonic, one section or one segment with good permeability will produce first, will contribute first, but later on, another layer, another segment, or another compartment with poorer quality will contribute later on. So that's why you will have the curvature, because the support or the contribution from other layers come later on. Okay, so that's the practical way for us to understand exponential, harmonic, and hyperbolic. With that being said, let's go to the main course. So B factor in decline curve analysis for each system characterization and identification. I take this data from this excellent book, Reservoir Engineering book by Tariq Ahmed. Okay, so you can read it with me. The following is a tabulation of the values of B that should be expected for homogeneous single layer or layered cross-flow system. Okay, homogeneous single layer or layered cross-flow system. So let's start with B equals to 0 or exponential decline. We have this case for gas wells undergoing liquid loading, wells with high back pressure, high pressure gas, right? So gas reservoir with high reservoir pressure. So yeah, gas will produce relatively easy compared to oil. So you can imagine that you will produce with faster decline rather than curved production trend like what we have in hyperbolic or harmonic trend. Okay. And low pressure gas with back pressure curve exponent of N equals to or around 0.5. Poor water flood performance for oil reservoir, right? So if you have water injection or water flood, but you know that the performance is relatively poor, then you can expect your production trend will be closer to exponential decline. Okay, because in water flood, you expect that the water will have a good efficiency, good sweep efficiency, so that you expect later on segments or compartment or area with poor quality will be swept by the water and contribute to the production later on, which will give you hyperbolic trend. But if you don't have good performance of water flood, then all those segments, all those areas, all the oil in those segments will just be bypassed. All right, so they will not contribute to the production and you will not have hyperbolic effect later on. Okay, all right, so that's poor water flood performance. And then gravity drainage with no solution gas. Okay, gravity drainage with no solution gas. Or solution gas drive with unfavorable kg per KO. okay? Still in oil well case. So if you have this case, then your production trend will be closer to B equals to 0 or exponential decline. Okay, so I think that's all. I will close this video with discussing only about exponential decline or B equals to 0. For B greater than 0 and below 1, where we will have hyperbolic or harmonic trend, we will talk about this later on. Okay, so I hope you enjoy this video. I hope this video is useful. Thank you so much for watching and see you again in the next Eng-Man videos. Thank you.